temperature rises, therefore glaciers disappear and sea levels rise.
Gotcha. It's a much more complex system. So where does CO2 and carbon get to be the main focus of the whole dynamic and the basis for new international law?
You know, Kim, can I jump in here?
Please.
This is Willie Soon.
Yes.
I think we should just get back to at least the basic questions that we find it surprising in terms of the level of scientific understandings in our world. It is somewhat surprising, actually. I didn't even dare to ask this kind of question maybe 10 years ago, but I do ask that very frequently these days during my talks and all these places. I started to ask people, how many people know that how many % do we have carbon dioxide in the air today?
That's a great question.
Yes. Do you care to answer that?
I certainly wouldn't know, even though my last name is Greenhouse. Don't assume that I know.
I see. So maybe we'll just cut to the chase by giving the answer away. Well, essentially that it was very surprising. Even some very, very smart people will answer something like, hey, about a few %, things like that. But of course, that's completely wrong. We know that because the number is actually 0.039 or 4%, 0.04%. That really means 4 cents out of your $100. And indeed, think about it that way. This is the reason why it's surprising is that it shows that how we are being brainwashed in a lot of ways by the media, including even the scientific organization, for example, who do not really care to explain to people what some of these basic facts are. And it's very, very surprising. Of course, the bottom line is that they say, because we're going to change, let's say, 100 parts per million, they try to make the number looks large, right? But that's equivalent to, again, 0.01% of the atmosphere, which really is very minute, isn't it? And then they started to say, well, these will cause all the disastrous effects, right? And we can talk about polar bear in a minute. We can talk about the ice. We can talk about the, for example, basically species extinction, for example. And they started to go down the road of all the disastrous effects. And then at the same time, it's very surprising when people try to point out, yes, hey, we know that the Earth climate system is basically been undergoing this thing of natural cycling in the sense that you have this period of warming and cooling, right, all the time. And all of a sudden, when man comes along, we emit this carbon dioxide. Again, remember, the amount is extremely small in terms of the volume measured in the atmosphere. And how come this will totally control and take over, essentially, the whole climate system, such that whatever that anything else do, even how the ocean current can move, let's say, the heat from Antarctica to North Atlantic, for example, that would not matter. That's a very surprising. Worse yet, they will say that no matter what the sun does, it also doesn't matter because its CO2 is going to be that important. Okay? To put it in a simpler sense, if you ask yourself then, how much then the power that can be given by this carbon dioxide versus, let's say, the power that could be given by the sun? It's basically the sun is at least 10 times stronger in a sense, right? And then there is no doubt then, in my opinion, if you were to any changes in the sun would dramatically have a very, very strong control on what the system will do.
Can you explain something, speaking of the sun?
Yes.
I was speaking with an astrophysicist a couple of months ago, and he said that we're in solar cycle 23 and about to go to 24, and that astrophysicists haven't seen this kind of inactivity in the sun in a long time, and it's alarming. What does that mean?
That is simply just referring to how we think that the sun, as we discussed earlier, that the sun's surface are usually speckled with all these dark spots, magnetic sunspot, right?
Right.
And we are in a sunspot minimum right now, that's true. But then the amount of number of spotless day that we observe, let's say since 2008 until now, is extremely low. It's extremely extended time in the sense that we haven't had a time like this that we have that many days of spotless day. And indeed, this is already breaking the 100 years record for sure. And then, of course, when it comes to weak sunspot activities, one, of course, would like to suggest that because of less energy output coming out from the sun, that perhaps the Earth system would go towards the cooling tendency. And that is indeed, we know that, let's say, a period known as the Little Ice Age, that happened from about 1300 AD to about 1900 AD or so, where we know that the glaciers were growing and things were so cold and perhaps situation were getting drier and drier. So all the water was started to store in this glacial mass and ice sheets and so on and so forth, that those periods are extremely cold. And guess what happened then to the sun's magnetic activity? And we do know for a fact that for a period of time in mid to late 17th century, from about 1645 to 1715 or so, this period is known as the solar Maunder minimum. In fact, I was so curious about this particular period that I wrote a semi-popular book on this to try to explain this phenomenon of the solar Maunder minimum.
What's the name of your book?
It's called the Maunder minimum.
And would the average person be able to understand it, or does it start at an astrophysicist level or climatologist level?
I would only label it as a semi-popular book in the sense that I wrote it. I attempt my best to write it in the layman sense, but then I also try to achieve the hallmark of being a very, very original manuscript, which means the world has not done this sort of research before. So I don't know which way to say about this, but of course, if anybody wants to read on it, please do. And I do believe, of course, it contains a lot of very, very original materials that has never been said before. But the whole purpose was indeed to find out what is this phenomenon of solar Maunder minimum is about. It is indeed about a period of very weak magnetic field on the sun. It is indeed a period of the time from 1645 to 1715 or so that the sun barely have only a few sunspots.
Is that
which is very, very unusual. Remember, a 70 years period that you don't have that much of a sunspot, which is highly unusual. In fact, on the northern hemisphere of the sun, there were only 2 sunspots that has been known. And those are observed by people from the Paris Observatory. When they saw those, they were so excited, they're beginning to write papers on it. It's just a fairly interesting phenomenon in all by itself. That, hey, we got 2 sunspots, better write a scientific paper on this. And that was so excited at that time. But anyway, so that period was really is a period that is distinguished by its lack of sunspot, of course, appearing on the sun. But then, since then, in the modern age, space age that we're in now, we have also been able to confirm, of course, this Maunder minimum phenomenon by using a completely different independent measurements. This can be done by basically measuring the radioisotope of carbon-14 in 3 rings, or measuring another one called the beryllium-10 isotope in ice core, that one can find that indeed such a period, during period of solar Maunder minimum, there was a lot more production of the carbon-14 and the beryllium-10 isotope in the Earth's atmosphere. You can produce a lot of that because the sun's magnetic wind is very, very weak at that time, so we are a lot less shielded away from basically the incoming galactic cosmic ray that can produce such isotope. So this is, of course, that very interesting inverse relationship between the magnetic wind of the sun versus the isotope production on the planet Earth.
Willie, I have a quick question here. So people who measure ice cores can tell what's happening with the sun?
Yes.
We're not dependent on NASA for this.
Yes, indeed, there are plenty of research funded by the European Science Foundation or National Science Foundation of our U.S. National Science Foundation, and even, I would say, private donation of people who funded my work, for example. We all have been working very hard to try to learn about the history of the sun itself. And this is basically, of course, in a goal to just studying the sun for sun's sake. We don't have to try to claim that it's ever so important for climate, but then I think the indirect benefit of that kind of in-depth study would be very beneficial towards gaining more understanding about how the climate system itself changes or not changes, for example. So we do have that sort of coincidence or that kind of confirmation that during solar Maunder minimum period, 1645 to 1715, in northern Europe is extremely cold. We know that. And we have, frozen lake, and frozen rivers and Thames and the Dutch ice skating phenomenon, so on and so forth. Those are all really fits very, very well in terms of the magnetic history or the sun's light history in respect to our Earth history itself. And the point is that we can not only confirm such a thing for the